Welcome to our sustainability series, part of the New Steps Safe Future projects. Water in engineering. Our planet Earth has been called the Blue Planet since the days of space travel, because the water covering almost 3/4 of its surface shines blue when seen from space. It is this water that sustains life on Earth. Because of its importance, ancient Greek philosophers considered it one of the 4 primordial elements. In Hindu culture, it is seen as a symbol of life and purity. The first civilizations developed next to water because it was used and is still used today as food, as an agricultural and industrial auxiliary material, and as a source of energy. The water is also present as a destructive force, which we see during the natural disasters that regularly occur today, floods, tsunamis. So man's relationship with water is twofold: to use the opportunities it offers and to protect against the threats it poses. The related technical tasks are solved by civil and mechanical engineers using engineering tools and methods. These professionals work in close cooperation. Buildings are needed for mechanical equipment. Machines are needed to operate water systems. Engineering work continues with the design of networks, artifacts, mechanical equipment, and buildings. They have to be built, assembled. The completed systems have to be operated, checked, maintained, and renovated. Engineers also carry out the research and development of new technical possibilities. Human groups always settled near natural waters, environs of springs, riverbanks, lake shores. The growing population of the cities that formed in ancient times did not have sufficient water for drinking and household and hygienic purposes, so this had to be brought there from a greater and greater distance. The aqueducts and aqueducts built by the Romans can still be seen today. The 130 kilometers long, 3-level aqueduct built to supply ancient Carthage, which brought spring water from the mountains to the city, was considered one of the wonders of the ancient world. It was located in the territory of Budapest, next to the ruins of a former Roman city, Aquincum. In addition to transporting fresh water, wastewater had to be removed. The remains of the first built sewer system, the Cloaca Maxima, Rome, can still be seen today. Where it was difficult to ensure a continuous water supply, it was necessary to build reservoirs. Here, in addition to the architectural tasks, protection against leakage also had to be solved. The first such structures were the huge cisterns of the Mashoda fort on the shores of the Dead Sea, or the Chantbori in India, which is a 13-story stepped storage well. At that time, no machine helped the water reach its destination. It was ensured by the properly designed slope of water pipes and canals under the influence of gravity. Today's water networks often get water from below ground level, and pumps move the water in these systems. Their operation is supplemented by the pressure of the mass of water pumped up into the water towers, so that the water reaches the higher floors and the houses built on the hill. The task of raising the waters has appeared. Canals were dug to drain the groundwater of the marshes. Dams were built against the destructive effects of floods. This is how the canal and dam system of the Netherlands has evolved today. Even in ancient times, water was raised with simpler machines. Such is the Sadif known from Egypt, whose operating principle continued in boom wells until the last century. Another technical solution is the Archimedean screw used by the Greeks, which is the oldest known pump. Despite its simplicity, this is still used today. A few years ago, a small hydropower plant was built in Hungary, in which 2 such structures were installed. They serve as turbines. That is, the water coming down from the higher level turns the spiral of the snails, and the rotational energy is converted into electric current. The energy obtained from water could always be used favorably. Water wheels were built for this purpose. The water of the streams and rivers was either led to the wheel from above or flowed below it. So we speak of a water wheel with an overhead or under-applied water wheel. If the water flows over the wheel from above, it is called an overflooded water wheel. If the water runs out under the wheel, it is an under-drained water wheel. With the spread of electricity, it became possible to transport the energy of water to more distant places. In the hydroelectric power plants built for this purpose, the water flows down from the dammed lake, from which the energy is obtained. The water drives a turbine, which transfers its rotational energy to a generator that produces electricity, which is then transported to the place of use as electricity. Tidal power is a modern type of hydropower. The electricity generated by power plants can be used further afield. Due to the growing population and increasing industrial and agricultural activity, the demand for water is constantly increasing. Water-saving or recycling solutions come to the fore. Demands arising from changing attitudes will continue to pose new challenges for engineers in the future. It is more and more important to use water-saving solutions, to treat wastewater and, most importantly, to keep aquifers clean.